If you look at fraction addition with how we make fractions out of circles, that's also fine. We have a few projects also based on this. You can use the projects as well that were made in Scratch. But I think the first question to start off is, so if you have some fraction, okay, let's say it's this itself, right? How do I know what it is? How do I know what this fraction is of the whole? How much of the cake is that, right? Okay, so maybe it would have been 1/4, but it's a little more than 1/4. So this is, I cannot make more pieces like this and fill up the hole. There will be something that will be sticking out, right? So the one way to figure out what that is to have enough pieces in the hole. You can do it nicely, but if you have enough pieces in the hole so that this forms a whole number of those pieces, right? Then I can say, okay, this is let's say 5 out of. It's a little more than 1/4, so let's say 5 out of 20 would have been 1/4, so it's a little more. So let's say it's 5 out of, let's say, 80. Okay, so the fraction, a fraction itself is defined as how many pieces are there. So these are whole number of pieces. So let's say I wanted to add 1/3. So this had 2 other pieces. You can tell, right? I cut something in 3 pieces and I said 1/3, so 1 out of 3, yeah. And I wanted to add it to half. Fine. If I have these pieces, very easy to add, this is what I get. Now the question is, what is this fraction? I can't have more pieces like this, yeah. So to fill in 1, so I need to break it into small enough pieces so that I understand what that fraction is. Otherwise I cannot add fractions. So when I'm doing equivalent fraction, I'm saying, okay, this 1/3, if I broke it down into 2 pieces, is 2 out of 6. It's easier to see this way. Yeah. So it's the same as 2 out of 6. And this half is the same as, so I'm cutting it into pieces. I can cut it in half. I'll get quarter. But quarter is not the same size as that. So they are not the same size. Unless they are the same size, I can't say it's integer type of the same. So basically, because it was 1/3, I divided that by half. And because this was half, I divide this by 3. Because there was a 3 and a 2. Then I'll get 3 pieces of this. And they are all the same kind of pieces. Now if I add them, it's fair to say that half plus 1/3, that shape that we could not tell what it was before, we can tell what it is now. It is 5 out of 6. So the equivalent fractions that we do, which is we take 1/3 and we say, okay, that's 2 by 6. Or it could even have been 3 by 9 and so on, right? So these are all fair representations. They are just equivalent representations of the 1/3. But only when the pieces are the same kind or same size can I add them. So if I did even half and I did, oh, okay, this is also 2 by 4. Pieces are not the same kind. Or it is 3 by 6. I say now pieces are the same kind. These two I can use. And I can say that if I add these two, this is equivalent of adding 5 out of 6. So essentially in fraction addition, you have to have pieces of the same type or same size, and then you can know the result, because then you're just like adding integers or adding numbers. So why doesn't adding just the numerators and denominators work, right? This is a question many children have. Okay, so that would be like saying, okay, this was 1/3, so there are 3 pieces, but of this size, yeah, remember it's of this size, and I had half, which was 2 pieces. So you're saying, cut the whole into 5 pieces. Now those 5 pieces are neither like this nor like that, and then say 2 out of those 5 pieces, right? So I'm going to have smaller pieces, and I'm going to say, no, I just have 1 of this and 1 of that, and that doesn't really work. So that's why 2 out of 5, if someone writes 2 out of 5 saying, it's the same number of pieces, well, it's not just total number of pieces that were there before. You need to know what does your final fraction look like, right? When you put the two together, what does this mean? And that's the difference.